Homework Hotline, what is your emergency?
Hello, thanks for tuning into the Homework Hotline. I'm Becca, a math teacher at Emily Griffith High School.
Welcome everyone. I'm Sam, a science teacher at the Contemporary Learning Academy.
Our other math teacher, Nate, couldn't join us this show, but he'll be back again tomorrow. But still, I have a feeling that today's going to be a great show.
Yeah, it's always a great show on Homework Hotline.
Very
We love
true.
being able to help you guys with your homework questions.
Agreed. So if you are stumped with that math homework or tangled in a web of science, give us a call and I can help you with all your math questions.
And I can help you with all your science questions. We're here every Tuesday and Wednesday from 4:30 to 5:30 p.m. Call us at 720-424-1666. We love to get your calls, and it helps us to help you better when we can talk with you about your problems.
So you can watch our show in several different ways. For live broadcast, you can watch us on Comcast Channel 22 or go to livestream.com and search for EG Homework Hotline. If you'd like to see some of our past shows, watch us on YouTube by searching for DPStv Homework Hotline.
The Homework Hotline is sponsored by the Contemporary Learning Academy and Emily Griffith High School. In fact, one of Emily Griffith High School's students, Lily, is also a part of our team. Lily, would you like to tell our stellar audience about yourself and what you do here?
Hi guys, I'm Lily and I am a senior at Emily Griffith this year. The Homework Hotline wants to be accommodating to those of you who love to turn in your questions on social media, and I help get those questions over to Sam and Becca today. And also, I am the trivia queen, so at the top of each show, I will ask you, the audience, a trivia question, and before the end of the show, I want to hear the correct answer from you. And so the trivia question today is, what can you use to identify dogs like you would do in fingerprints in humans? And we will answer that at the end of the show.
Very interesting. I wonder what the answer to that is. So if you think that you might have an answer, give us a call at the phone number that Sam gave you earlier, but you can also get us a call with homework questions, or you can give us answers to trivia questions via social media. There's some other ways to contact us. So you can get us through social media, as Lily mentioned. That contact information will go on your screen in a second. It's you can get a hold of us on Facebook or Twitter at EG Homework. You can text us as well. That phone number should be coming up on your screen in just a second to text. You could also email us at eghomework at, I don't remember the email address, it's not up on the screen. It's homework@emilygriffith.edu. I'm sorry about that. So all the ways that you can get in contact with us, all up on your screen right now, so you've got a lot of choices. We are here until 5:30, so we can get all of your questions answered. Just get a hold of us in one of those ways. So that being said, let's go over to Lily and let's get some of our social media questions started today.
Okay, so let's start off with a math question that asks to solve for x, and it's the absolute value of 2x plus 5 equals 9.
Okay. I've got the equation written on my screen, and then I'm going to give you kind of a brief background of what absolute value is, so maybe it can help with understanding how to solve this actual equation here. So if you cut to my screen, I've got the equation on my screen that was asked, and we were asked to solve for x. These two little lines here are the parts that tend to be a little bit confusing. As Lily read correctly, these are called absolute value. And the absolute value, the definition of absolute value is the distance of whatever's inside of those bars from 0. So for example, and I'm going to kind of go on the side here to explain this a little bit more. If I did the absolute value of -2, what I'm thinking of is if we thought of it on a number line, here's 0, here's -1, here's -2. And so if we're finding the absolute value of -2, what we're thinking of is what is the distance from 0. So it's actually 2 spaces from 0. Now, we also have something else that has an absolute value of 2, and that's going to be the positive version of that. So +2 is also going to be 2 spaces away from 0. And so we have something that's positive that gives us this absolute value of 2, and we also have something that's negative that gives us the absolute value of 2. And so when you're solving equations like this, you want to consider the positive and the negative aspect of it. So what we do is when we get down in our equation to where all we have on one side of the equation is whatever's inside of those absolute value bars, we want to write 2 equations for it. One of them is going to be the positive version of it. One would be the negative version of that. And so the first equation is the positive version. So positive version, when I say that, I just mean write the equation as you see it. The negative version would be making everything on the right-hand side of the equation the opposite. So we'd have one equation, 2x plus 5 equals positive 9. The other equation, 2x plus 5 equals negative 9. There are almost always going to be 2 solutions to absolute value equations, again, because of the positive and the negative version of it. So you always want to solve it. I would say the biggest mistake I see students make is they forget to do the negative version. They'll just solve the equation with the absolute value bars not there, which you can for the positive version. So from here, we will do both things, or do the same thing to both of our sides to undo and get our x by itself. So subtracting 5 from both sides leaves us with 2x on the left, and then 9 minus 5 leaves us with 4 on the right. Dividing both sides by 2, we get, for our positive version, we get x is 2. And then we also have to solve this negative version. So we're going to do the same steps to get our x by itself. This time we end up having 2x is equal to negative 14. And then we divide both sides by 2. And we get x is negative 7. So 2 solutions to this equation. One of them is 2. One of them is negative 7. The answers will not necessarily always be one positive, one negative, but we derive them from the positive and the negative version of the solution. And the reason why is because absolute value has both positive and negative connotations. So there you have it. Get us more questions like that if you do have some more questions on that topic. So let's go back to social media with Lily and get some more questions answered.
So this one asks that someone told them about something called dihydrogen monoxide. They ask, what is that?
Okay, nice. Well, then this is definitely a science question. All right, well, the person who asked you about dihydrogen monoxide may have actually been playing a bit of a joke on you. It's a joke that I definitely see science teachers play on their students once in a while. And the joke is essentially this. What you've got here is a formula for some kind of a chemical, all right? Dihydrogen monoxide. What that tells us is that there is hydrogen in this and that there is oxygen. The oxide stands for oxygen. So we know that this chemical, whatever it is made up of hydrogen and oxygen. And I want you at this point to ask yourself, can you think of any common chemicals out there, let's say, out there that contain hydrogen and oxygen? The second thing to do here.
H2O.
Oh yeah, very nice. Very nice. What's H2O, Becca?
Hydrogen, and then is it two hydrogen and 1 oxygen.
2 hydrogen and 1 oxygen. And so another way to say that is dihydrogen monoxide. So di stands for 2. So dihydrogen, 2 hydrogen. That's the H2 in that common formula, H2O. And then mono stands for 1. So monoxide means 1 oxygen. So dihydrogen monoxide is just a very scientific, very chemistry-oriented way of saying water. And one of the jokes that science teachers often play on their students is they'll give them papers that say that there's this chemical out there called dihydrogen monoxide and it's in everything. And water has some potentially negative impacts, like it can be involved in gigantic storms, it can cause corrosion to happen more quickly. And so all of those things can be said in a way that can make you think, oh my gosh, this chemical, dihydrogen monoxide,
chemical.
It's out there killing everything or destroying everything. And in reality, it's just water. That's all it is.
Oh, that's kind of a mean trick.
It is a little bit of a mean trick, although, you know, I think we get bored up there sometimes teaching science, try to add in a little bit of fun, play a trick on our students.
Makes sense, makes sense. Well, and it's another kind of example. If you know the vocabulary of whatever subject it is, then you can figure a lot out.
And that's actually
it's
a really good
not
point.
all that difficult if you know the vocabulary.
That's such a good point. I mean, even though it is a joke, right, that teachers might play on their students, it might be a joke that'll teach you something, because remembering that di and then whatever the chemical is tells you that there's 2 of that particular atom, and then mono tells you that there's 1 of that particular atom. That's a skill that you could use in a lot of different places in chemistry. So sometimes there are these jokes that we can actually learn a lot from.
Makes a lot of sense. Yeah, that's true. I'm going to think of some math.
Are there
ones.
math jokes
I'm
like that?
sure
Is
there are.
anything? There's
I'll
gotta
come
be
up with them
something
in a
good.
minute.
Like mean jokes to play on your students, but then they learn so much from them. Anything?
Not mean jokes. I don't really have any
Sure.
mean ones. I do nice ones. That if they can figure it out, then they understand the joke.
I mean, I think that can be really positive. That could be a really great way
I've
to
got
learn.
some that are kind of good.
Well, let me know if you think of any.
All right. That's true.
That was a funny one.
I put some, when we learned about imaginary numbers, I put some comics up on the board that it's an imaginary, it's a square root of -1 sitting on the couch, and he's saying, or he's on like a therapist chair, and he's saying, am I real? Do I even exist? Because
That's
imaginary
great.
numbers, yeah.
Imaginary number
So
jokes.
funny.
Nice.
Yep, so definitely some content related jokes.
Right,
you
there's
can get
something
to
out there.
All right, well let's actually go get some more questions answered from Lily.
So we have a slope-intercept question that asks how do you write 3x equals y in slope-intercept form?
Okay, I can definitely help you with this. And actually, this is kind of another example of if you know the language, if you know the vocabulary in the subject, it's not something that's all that difficult. So the question was, how do you write 3x equals y in slope-intercept form? So if you could go to my screen, if we can look at my screen, I'll break this down for you. So slope-intercept form is basically a form of a linear equation that, in that form, you can see the slope and you can see the intercept, the y-intercept. So, which is, if you are familiar with, and a lot of you might be, this is the most widely used form. Sorry, my pen is malfunctioning. Y equals mx plus b. The reason this is called slope-intercept form is because the m, this coefficient of m, represents the slope, and this coefficient, or this constant, b, represents the y-intercept of the equation. Now, thankfully, whenever you are asked to put an equation in slope-intercept form, pretty much just means make it look like that. And so the characteristics of slope-intercept form is that y is by itself. It's isolated. And actually, this equation that was given here, the y is already isolated as well. It's pretty much in slope-intercept form. The only difference is it's on the other side. I'm not sure if the teacher matters about that or worries about that, but we could also rewrite this like this. Now, you can kind of see here we have this coefficient in front of x, 3, just like over here, this m. So we're almost in slope-intercept form because you can see the slope, but we can't quite see the intercept. And the reason we can't see what the intercept is because it is this, plus 0. So this equation that I just wrote here is still equivalent to the one up top, because when you add 0 to anything, it doesn't change it. But now it's actually written in that form so that you can see the slope, and you can also see the y-intercept in it. So the slope is 3 on this particular one, if that's something you needed to do with it. Slope is 3, the y-intercept is at 0, y equals 0. So hopefully that helps. Again, knowing the vocabulary really helps sometimes figure out the problem, or helps you decipher what is being asked, and it's actually not all that difficult if you know the vocabulary. So. Right,
and it's nice that you can make it meaningful by saying something like, so slope-intercept, here's the slope in the equation, here's the y-intercept in the equation, that's why we call it that. I think that definitely students sometimes get caught up in that idea that I have to call it this, but I'm not sure why I'm calling it that.
Slope-intercept, right? It just sounds so complicated.
Right.
But really, if you break it down, it's not all that complicated. It's
I think we're majorly guilty of this in science, of creating these big words for concepts that are really, in the end, maybe not that tough to understand, but the words are almost a barrier.
That's so true. They are a lot of times, too.
Yeah, it's very interesting.
Very right. Very right. All right, what's next? What are we doing next?
Oh, I think maybe kicking to Lily for a question off the board.
Great. All right, what do we have?
One more question. It says, what is the crust of the Earth made out of?
Oh, nice.
That'll be you.
This is an awesome question. So I really don't get enough time in my day to talk about geology. It's one of the things I'm most interested in. And I think it's partially because we're walking around on this giant thing, the Earth, and it's cool to know what it's made out of and how it works. So what this question is asking is sort of what is the chemical composition of the outer layer of the Earth. So the crust of the Earth is just this very, very thin layer of the Earth that's on the outside of it. And you can think of it in a sense, it's crust almost in the sense of pizza crust. It's the thin layer way on the outside, except that the Earth's crust is much, much thinner by comparison to the rest of the Earth than a typical pizza crust is to the rest of the pizza. But what this question is really getting at is that what changes about the Earth's composition as you get deeper inside the Earth is that the metals and the chemicals that make up the Earth get heavier. So on the outermost part of the Earth, on the crust, what you're going to have is the highest levels of a chemical called silicon. So silicon is an element. It's an element that is very light, and it's an element that actually is part of a lot of rocks that have a lighter color. Now, that's not always a good rule, but if you're walking around and you see lighter colored rocks such as quartz, quartz is made entirely of silica, sometimes with a couple other things added into it. The crust of the Earth is made largely of silica with a lot of aluminum and oxygen thrown in as well. As you go deeper into the Earth, the amount of silicon, it lessens, and what you end up with more of is more iron, and you end up with more nickel. So in the crust of the Earth, we have maybe 8% of the crust of the Earth is made of iron, but as you get deeper and deeper, a much larger portion of the Earth is made of iron, and then as you get into the deepest center part of the Earth, the core, you have a core which is made largely of iron and nickel, and much, much less silica. And there's a reason behind that, and the reason is that these heavier elements, just like, let's say if you have a cup of water and you drop some coins into it, the coins are heavier than the water or more dense than the water, so they're going to float to the bottom of the cup. You have these heavy elements in the Earth that are floating to the center of the Earth effectively and staying there, whereas the lightest elements are floating on the outside. And this is a strange thing to say because we talk about floating and sinking, and we're talking about rocks here, and it's hard to imagine rocks sort of sinking into each other. But inside the Earth, we have a liquid mantle, and we have this ability for rocks to sink and float past one another, and so the lightest tend to come to the outside, and the heaviest tend to go to the inside. And just for a really quick review, silicon is going to be the element that's lightest, iron is going to be very heavy, but nickel is going to be the heaviest. And those, when we think about what part of the Earth we're looking at, it's the levels of those three elements that are really most important. Did that make a little bit of sense to you, Becca, as I was explaining it?
I was thinking of like gasoline or oil and water too.
Oh,
just
yeah.
that same idea of the different densities.
Absolutely.
And how they, they do mix a little bit, but as they settle, the denser.
The denser stuff floats down, and the lighter stuff goes
gravity,
up, or the less dense. And it really is, it's such an important thing that we see in so many different aspects of the world. I sometimes think we don't do enough to talk about how important density is, because just getting this concept of density allows you to understand a wide range of things that we talk about in science class that, again, they get bogged down in the vocabulary, we get bogged down in sometimes the math, honestly. But it's just, if we just understand that core concept of the more dense things are going to float lower and the less dense things, it's incredible what it can teach you about, like, for example, climate and wind. Really, the formation of wind and understanding why we get wind in a particular place is really all about understanding I've got cold air and I've got warm air.
Right.
And
cold air is more dense.
Than
exactly. Warm air, and so then you have,
You have a mixing based on that. So a sinking of the cold and then a rising of the warm. And luckily for us, our Earth is spinning around. And so we get, a portion of the Earth exposed to the sun, warming up the air, and a portion of the Earth that's not exposed to the sun, cooling down. And that natural heating and cooling is actually what's most responsible for the movement of air. A lot of people think that just the spinning would do it, but
yeah, no, it makes a lot of sense.
Yeah, it's all about density, or many things are about density, I should say. So
it makes a lot of sense, really does.
Cool.
All right, well, we're going to take a little bit of break from this, and we are going to watch a real-world app, see how arts and also possibly science can tie into. Well, I'll let you check it out.
Nice.
Hi, I'm Luigi, and we are here at the Denver Art Museum for Real World Apps Chemistry. We're here at one of the 3 conservation labs at the Denver Art Museum with our 2 art conservators. What are your names?
My name is Sarah Melching. I'm Director of Art Conservation here at the Denver Art Museum.
And I'm Courtney Murray, and I'm a graduate intern at Denver Art Museum in Objects Conservation.
So for those at home who may not know what an art conservator is, what is an art conservator?
Well, an art conservator is someone who's responsible for the long-term preservation of artwork. And we work to preserve by 2 methods. Preventive conservation is sort of like controlling the environment so that we can slow down the degradation of materials over the long term. And interventive conservation is where we actually intervene to bring something back to sort of how it should look.
We want to ensure that your grandchildren and their grandchildren thereafter will be able to appreciate them.
Both of you obviously went to school, as you said, you're a graduate intern. So what was your undergrad work at, college?
I attended the University of Kansas, and I have a Bachelor of Fine Arts in the history of art. I primarily studied a lot of studio art history, as well as a foreign language.
My undergraduate degree is in chemistry from Emory University, and I studied chemistry as well as art history and visual arts. So sort of the opposite of what Sarah did.
Many of our viewers are in high school, so I guess the question is, if they want to become an art conservator, do they necessarily have to be a good high school student?
In my experience, I've met people with, varying degrees of enthusiasm and success in levels of school along the way. To get into the graduate school programs, however, you do need to show some consistency in your earnestness and achievement in academics.
And it is not only science that happens here, it's very art heavy. So what got you both interested in art in the first place? I mean, especially like yourself, you said you were very science-y at first, and then the art sort of came along, so
ever since I was a little kid, I loved to work with my hands. I was also very practical, and I loved the science part. So I knew I didn't want to work as an artist alone. I've never been the most creative person in the world. I'm good at mimicking someone else's work, but I've never been good at coming up with my own body of artwork.
I've made art my whole life, but another sort of fixation of mine as a child was fixing things. And so when I figured out I could combine art and fixing things, I thought, I found it, I figured it out.
do you have to be an artist to be an art conservator, or?
I always have said that anyone can learn to make art.
What chemicals would you guys use preserving a sculpture or an art or a painting?
When it comes into our lab, one of the first things that we do is spot testing. And essentially what we're doing is sometimes there's an old adhesive or an old coating on a sculpture that we would want to remove. So we'll do some tests with different solvents to determine what solvent is appropriate to pick up only the layer that we want to remove without damaging the layer below.
So we've actually got a piece here that Courtney is actually working on. Who is this guy?
So this piece is actually King Caspar of the 3 kings in the nativity story, and he was made in 18th century Ecuador. And they're made to be devotional figures, and they were used in churches or in homes. They could be paraded around. And so this is King Caspar, and he actually has a horse that he rides on normally, and I'm also working on the horse. But the horse can't stand up right now, and so that's why Caspar is sitting on this
Mailbox.
foam horse at the moment.
So this is actually gold on here that we can see that's kind of been rubbed on there.
It's called gold leaf. It's really thin gold that's pounded into sheets, and then it's applied to the surface. What I'm doing to King Caspar is he came in, and so what I'm doing is I'm actually filling the joints. You can see the white there is my fill material that's bridging the gap. He is missing a couple of fingers, and I have them here in my hand.
They're tiny.
So I made them separately, and I will attach them with an adhesive so that they can, of course, be removed later if somebody would like to do that.
A very clean and professional job by the art conservators at the Denver Art Museum.
Welcome back. Hopefully you got some information from where you can use some science and where that crossover might be with the science and the art. Kind of interesting. So we've got a caller on the phone right now. So can you hear us? Hi.
Hi.
How are you?
Good. How are you?
Good. Do you have a question for us?
Yes, I actually have a science question.
Oh, great.
Okay, nice. Well, go ahead. Hit me.
Why do ocean currents cause climate change?
Oh, yeah. Okay. Well, this is
we're kind of just
a
talking
great
about that a little
question.
bit, right?
Yeah. We were kind of having a discussion sort of related to this
Kind of.
a minute ago. And I think that this is so relevant too because we're living in, as many people probably know, what is going to be an El Nino year. What people are talking about as either a medium or maybe very intense El Nino year. And so I think that this is very relevant. So let me see if I can pull up a picture of ocean currents on my computer here. There's this, okay, perfect. Can we take a look at my computer, please?
Are you watching, by the way? Can you see?
Yes, I can.
Okay,
Oh, very
great.
nice. Yeah, thank you for
No, that's okay,
reminding me
because
there.
sometimes they're not watching and then we'll
Right,
make
and
sure
then
they
the
knew
picture is
what
totally
you were talking
unhelpful.
about.
Okay, so are you able to see the picture that I put up on my screen?
Yeah,
Okay.
it looks pretty cool.
Yeah, it looks very neat, right? So as you can see that this is just a map of the world. And what we've got here is a belt, and it's a red and blue belt. And you can see on the red portion of the belt, it says warm surface flow. And on the blue portion of the belt, it says cool subsurface flow. And this gets right back to a question I was just talking about. So I don't know if you were watching earlier, but if you have the ability to go back and take a look at this, we talked a little bit about the idea of density and the idea that whether we're talking about air or liquid, denser things are going to sink to the bottom and less dense things are going to rise to the top. Is that something that you've maybe heard a little bit about before?
Yeah, we're learning that in school right now.
Oh, well, perfect. Okay, great. So maybe do you remember this from school? Which is more dense, a warm liquid or a cold liquid?
Let's see. Which is more dense?
Which is more, and it's okay if you don't remember, but if you do, let me know.
I'm not sure.
Okay, no worries. So a cold liquid is going to be more dense, and this is going to be true across the board. Anytime any material gets cold, it's going to become more dense, and anytime a material gets warmer, it's going to become less dense. And we can just kind of call that a rule across the board, okay?
Okay, that makes sense.
Okay, so imagine ocean water we kind of think of as just one big cup of water, right? It's all salty water. But in reality, there's differences in the water depending on where you go. And one of the major differences is how warm or cold the water is in a particular area. So maybe you can imagine shallow waters near the Caribbean. Can you imagine Caribbean islands, shallow, beautiful blue ocean? Can you imagine that?
Yes.
So that's going to be an area where you're going to get a lot of sunlight. You're going to warm a current right there. And you're going to end up creating warm ocean currents, for example. In different areas of the globe, you get warm currents or cold currents depending on the local climate. But then all of those warm currents and cold currents together are going to be what sort of help to create ocean climate. And then ocean climate is very closely related to atmospheric climate. So if you have warm water in a particular area, that's going to rise to the top of the ocean. If you have cold water, that's going to sink to the bottom of the ocean. And that rising and sinking action, depending on where it's happening, can actually cause movement left and right as well. So maybe you can imagine to the east, maybe there's a pocket of cold water, and to the west, there's a pocket of warm water. And what will happen is the cold water in the east will sink below the warm water in the west, and they'll sort of cross over each other. Is that something, does that make a little bit of sense as I'm explaining?
Yeah, that does.
Okay, great. Well, so, and then coupled with this, we just have to recognize that about 75% of our globe is covered in water, or the surface of it at least is ocean or sea. And so the temperature of the ocean or sea has a big effect on the air above it. And just like the ocean currents, the air above it, if it gets warmer or colder, will sink or rise depending. And so the sinking and rising of ocean currents has a direct effect on the sinking and rising of air currents, which is really, and air currents are the bottom line of what's going to cause atmospheric climate. So does that make a little bit of sense as I've explained it?
Yes, that does. That helps a lot. Thank you.
Okay, yeah, very cool. And definitely, if you're interested in looking into it, look into the connection between ocean climate and atmospheric climate. It's really interesting.
All right, I will.
Okay, thanks for calling.
Thanks. Bye.
Makes a lot of sense.
Yeah,
Very interesting,
very nice.
too.
And it's funny how all that stuff connects in. I feel strongly that, like, if you start talking about one science thing, then you go off to another, you might be surprised that you've stumbled back into the first just by virtue of how connected everything is.
And it's the same between subjects too. I mean, you almost don't realize that our lives are not separated by chemistry, physics, art, math, geometry. It's not separated in these little categories. It's all very fluid, and it's all related. So
do you ever feel like maybe in school sometimes we do sort of a disservice by boxing everything in like that? And then because I know that when I left high school, I very much had this sense that, well, I'm going to learn about history, or I'm going to learn about math. I'm not really going to be a historical mathematician. I don't know. And then now, as I've grown up, I've realized, just like you said, everything kind of runs together.
Absolutely. I mean, I kind of boxed myself in and was like, well, I don't really like history, but I do like math, and I do like this. But that's not necessarily true. It's just because of the way that we've separated them. It's very interesting.
It totally is.
But we're going to go back to social media, back to Lily, and get another question answered.
Okay, so
What do
this
we
one
have?
says if y equals 14 when x equals 8, find y when x equals 12.
14 when x equals 8. Find y when x equals
12.
12. Okay, well, cut to my screen again. This is kind of the information that I was given is when y equals 14, x is going to equal 8. So what is y when x is 12? So I'm actually going to write this as like a table, like an input-output table where x is our input and y we're thinking of as our output. And when you think about input-output, what you're thinking about is what do you do to the input to make the output, what it is. So for example, when x is 8, our y is 14. So we're thinking about, so what do you do to this 8 to make the y 14? There were no hints about what kind of relationship it had. Sometimes they'll give hints such as, okay, it's an inverse function, or it's it varies directly, or it'll give some kind of clue. But since they didn't really give any kind of clue of how these are related, we could maybe assume a couple things. We could think of, well, to get from 8 to 14, we're adding 6 to it. So we take our input, add 6, that gives us our output. So if that's the rule, then our output, so plus 6, our new output or new y would be 18. Now, again, this is not necessarily what it could be. There could be maybe another answer. For example, I'm thinking of something. If I took my input 8 times 2, which would give me 16, and then subtract 2, that would give me my output of 14. So maybe that's the rule. You could say 12 times 2, and then subtract 2. That would give us another possible answer. So 24 minus 2 is 22. So really this question is relatively open-ended in the sense that the information they gave us allows for multiple answers. But what you basically want to do is use whatever clues you have. If there are more clues, get back to us, let us know, and we can, I can help you get that answer a little bit more exact. But what you're thinking of is you're thinking of a rule. What do I do to my x or my input to get to the output? And then you're going to apply whatever rule it is that you come up with, apply that to the next input to get your next output. So I just thought of 2 there. I'm sure if you're creative, you can think of maybe a different rule. So unless there's more information on that problem, there could be a variety of answers. I came up with 2 different ones, 18, 22. Other stuff would work as well. So hopefully that helps. If you do have more information on that question, get back to us and I can be a little bit more specific. So let's actually take a little break again. We're going to see a word from both of our sponsors, Emily Griffith High School and Emily Griffith Technical College.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. never mind from when, why, or how.
Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
We'll start loosening up those muscles for that rub. I can't believe how much Emily Griffith Technical College has helped me personally and my career so much. They really invested a lot into me. I really felt it while I was there as a student. And I think because of that love and support, I was able to have more confidence in myself. I've been able to open a business for myself. I can do anything I want, right? And I'm not talking about my schedule. I'm talking about that I can truly give back to the community.
Healthcare is going to continue to grow as a field, and pharmacy technicians are going to continue to be an integral part of patient care.
It can open a lot of doors for me as far as getting my foot in the door in the health industry.
Part of patient safety is having qualified personnel in the pharmacy environment. Employers will be looking for that as one of the qualifications. Once a student begins the program, you are enrolled in the hybrid portion of the course where you do online work and then come in and do lab work in the classroom. That portion of the program takes around 5 to 6 months. A requirement of the program is to complete 2 clinicals, and one in an institutional setting, and then the second clinical would be more in a retail environment.
It is more affordable than every other school that I've looked into as far as pharmacy tech programs go. And you can also get different grants to come here. I was actually able to get a grant for this program, and so that's really what made me decide on Emily Griffith's.
Once you've completed the coursework and both of your clinical settings, then the student has completed our program and is now ready to go and sit for the national certification test.
One of my goals in life is to be able to help people in some way, so that's why I chose it.
Hi, welcome back. Hopefully you got some information about 2 of our sponsors, Emily Griffith Technical College and high school. We've got a lot to offer, so if you are interested, look us up. But Lily's got something to offer as well. She's got some information to share.
So today on Facebook we have a mysterious tree that actually grew over 40 different kinds of fruit. And so today we are going to be talking about grafting. So yeah.
Yeah, this is actually called, it's a technique called chip grafting, which is actually a very old technique. And the way it works, and I'll let you explain this a little bit more, but the basic idea of the way that this works is you can take parts of, joined parts from 2 or more plants, so that, you know, there might be the roots of one tree and the actual, you know, tree trunk, and then we are cutting parts of, kind of like a Franken-tree is kind of what I was thinking, Frankenstein.
That's a good way to put it.
And you are using parts of one tree and connecting it to other parts so that you can possibly connect multiple types of fruits on one tree trunk, essentially.
Right. Absolutely. Like imagine you had a lemon tree growing in your backyard, okay, and you're thinking to yourself, well, you know, I've got lots of lemons.
Right.
But I've got way too many lemons, you know.
Right, I don't know what to do with all
I'm
this
trying
lemon.
to turn them into lemonade, but it's
all
not
this lemonade, but
working out. Well, so you say, okay, so maybe I could get some limes, some grapefruit, some oranges. So you go somewhere and you could literally then get a branch off of a lime tree, and a branch off of a grapefruit tree, and a branch off of a mandarin orange tree, let's say. And you would do this technique where you basically cut into the tree, and you make a pocket for the new branch to go. And my understanding is that it's nothing more than keeping it supported in place, at least with the old technique.
That's what I was wondering is, could I just do this in my backyard? Could I just cut
Right.
You know?
I mean, I think so.
And it
Although you would
seems-
have to have the right kinds of trees, right?
Right, right.
So two trees can't be too distantly related.
Makes
Let's
a
say
lot of
that might
sense.
be one issue.
Well, which makes sense because this can actually, the grafting can actually happen naturally. So if there are two trees that are growing so close together that they're touching, and they are so close together that they touch, they can actually start grafting with each other, essentially.
Yeah,
You
and
know,
it's just so amazing
if
that can happen.
something happens. So it can happen naturally, so that makes sense that I could probably do it myself.
You would think that you'd be able to. Well, so they do this thing in horticulture. There's a practice of you can create clones, right? Where you can actually cut off a piece of the tree, and instead of
right.
grafting it onto a new tree, you can put a chemical on the bottom that's called a root stimulator. And that chemical will create roots right out of the branch. And then you're able, once you grow it to a certain level, you're able to plant the thing right in the ground. And so that's, and what you're getting here is a perfect genetic copy.
So the benefits of this.
Right. Yeah, so I mean, the reason why we would want to do this is, and I've used the example of apples, I think, is one of the best examples to think about. So apples are native to Afghanistan, actually, which is sort of a really interesting thing about apples. There are forests, apparently, in Afghanistan that you can go to that have, they're apple forests, but the apples are all different sizes, like giant melon-sized apples and olive-sized apples and everything in between. And many of them are totally inedible and gross, like you would not want to eat them. And the modern apple that we have is the child of many generations of offspring coming from these ancient ancestral apples. And if you get a really great apple, like I think the most famous one I can think of is Honeycrisp.
Oh, yeah.
Have you guys had a Honeycrisp
I
apple?
like pink ladies.
I like Gala apples.
Pink ladies are good.
Yeah.
Galas are good. I tell you, Honeycrisp
Yeah.
is the best.
Yeah.
But when Honeycrisp was discovered, it was in a apple tree farming like factory, essentially. So imagine, 100 apple trees, all different, all randomly planted. And there's a guy, and his job is to go around and taste the apples that come off of each of these trees to see if he can find. And most of them are just, he literally takes them off, takes a bite, chews it, spits, not good enough. And 1 in 100, 1 in 200 apples is something that might be decent. And it's 1 in even a greater number that would be as good as like the Gala or the Honeycrisp. And if they find that one, that's the only version of this apple that exists. And now to keep it going, we've got to graft that into other trees and then make grafts of those grafts and grafts of those grafts. And so we're essentially cloning this one perfect tree. That's the
Right.
benefit to agriculture especially.
Could cloning lead to some sort of like mutation with the apples? Because I know like when you breed dogs, the same kind of dogs, it could lead to like disease and mutation. Could the same thing happen with like apples and or any kind of other
So you're
food?
talking about like incest among
Yeah,
dogs,
pretty
right? So that's
much,
like,
in a way,
so this
yeah.
is like if a brother and sister tree got
Oh,
together.
okay, gotcha. So
right?
it's just mother and
But cloning is like we take a
Like
dog
mother
and I
dog.
take the cells out of the dog and I grow that exact same dog.
okay,
So like
I see.
Fluffy, and I clone him, and then I've got Fluffy 2. It's not a sister of Fluffy. It's literally and that's why we need this
Oh,
in
like
agriculture.
like literally just the exact clone.
The
of,
exact copy, and so we would do that. We would get the exact copy.
Could I do that with my arm? Could I just cut off my arm and give it to my friend and exchange it and have my cells grow with my
Could you
friend?
graft your arm onto your?
I mean,
to your
could,
friend's
I mean,
body?
I'm
Is that
not
the
gonna.
question?
You guys don't think I'm weird.
grafting. I mean, there's bone grafting and
Oh, yeah.
skin grafting,
That's true.
and so some elements of.
I think that the technology exists. It's
sure.
just that we've never gone so far as to
Yeah, I
put
don't-
an entire limb onto somebody.
I don't
But
think we would.
it sounds science fictional, but really, I think that this is coming. I mean, they talk about
Makes sense.
all kinds of different things that we're going to be able to do with cloning in the future. A little creepy on some level, but maybe you could get your friend's arm. So
Yeah, right. I
totally
think it's
worth
cool
it.
because all you have to do is pretty much just tape it onto, or you can use like grafting tape or just wax, and you don't really have to like do anything specific with it. You can just like basically tape it to the branch you want it to grow from, and it's just pretty much go from there. You don't really have to do
almost
anything
like it was built
special.
to
Yeah,
do
pretty
it,
much.
yeah.
It's really cool.
Well, maybe
Very
let's try
cool
to do it
stuff.
here sometime.
So yeah, really, that'd be cool. Have a little apple
Bonsai
orange,
tree.
apple orange
Oh.
pear grape.
Yeah, that's
tree.
what I want. All of
Yeah,
those.
it would be difficult, but well, so we've got interesting stuff on Facebook. So stuff we could talk forever about.
No
So check us out on Facebook. We are always posting interesting things or things we find interesting, things you could learn from. So check us out there. But I am told that we've got a caller. So I'd also like to give you our call information. So if you didn't get your question answered yet, You can still get your question answered until 5:30. That's all the information. You see it on your screen right now. Via social media, we have no shortage of those questions, but also give us a call or text us. So that's all the ways you can get a hold of us. So we do have a caller, so let's get that caller's question answered. Hello, are you there?
Hello, hello.
Hi, how are you?
I am decent. Yourself?
Great, thanks for calling Homework Hotline. What's your question?
I have an algebra question.
Oh, okay, that'll be me. Let me see if I can't help you. What's your question?
The question is, the sum of two consecutive numbers is 37. What are the two numbers?
Okay, so consecutive, did I spell that right? Hang on, consecutive, how do you spell consecutive?
I'd have to write it down.
I'm confusing myself. Is this right?
C.
It's gonna bother me. Is
It's
it
a
C
C,
or Q? This
consecutive with a C.
is gonna really bother me.
You got
All
it.
right,
That's it.
anyways, two consecutive numbers is 37. So I'm gonna break down these words here, sum and then consecutive numbers, and
Okay.
then from there we're gonna figure it out. So do you know what sum means?
I sort of have a general idea, but I can't remember off the top of my head.
That's okay. So it's gonna be, and I'll give you a clue, so it's gonna be something to do with either adding, subtracting, multiplying, or dividing. What do you think it has to do with?
I'm going to go with adding.
Adding, you're absolutely right. So the sum is basically the answer when you add. So if we're finding the sum, or we're saying the sum is 37, the answer when we add those numbers together is going to be 37. So we have two numbers we got to add together to give us 37.
All right.
Do you know what consecutive numbers, what that means?
No.
So consecutive is meaning one after the next. So for example, two consecutive numbers, one would be 2, the next one would be 3. Or I'll give you another example, 10 and 11, 14 and 15, 38 and 39. Let's say I said 40, what would be a consecutive number to 40?
41.
Right, exactly. So the thing with consecutive numbers, them coming one after a next, the relationship is that one is always one larger than the other. So like 3 is 2, but it's plus 1. It's one greater than the one before. So if we're thinking about our consecutive numbers that we don't know, or unknowns, if we called one of them x, what would the next one be?
Either 2x or x squared.
You're close. So it's going to be always one more than the one before. So like, for example, if my x was 14, what's the next number?
15.
Which is just one more than x.
Gotcha.
Right? So the first one would be x, and then the second one we could call x plus 1.
Oh, okay.
Because it would just be one greater than that. So we know, so if we called our unknown numbers, if we called them x and we called them x plus 1, what we can do is write an equation using that, because we know what they're supposed to equal when we add them together. So if I took my x plus my x plus 1, I should get 37. So x and x plus 1. Now the idea is that if I figure out x, then the next number after that will be my other number. So I can use this equation now to solve. Does that equation make sense?
Yes, it does.
Okay. So then from there we can just simplify. So x plus x is going to give us 2x plus 1. And then we just want to actually get our x by itself, or get that variable by itself. So we'll subtract 1 from both sides. We get 2x is 36. Divide by 2. And then when you solve that equation, you end up getting that x is 18. So if x is 18, then what would be the next number?
19.
Exactly. And you can kind of double check your answer to make sure, okay, does 18 plus 19, does that give me 37? Yes, it does. So that means your two consecutive numbers are going to be 18 and 19. Did that make sense?
Yes, it does.
Great, awesome. So when you get clues like that, a lot of times you'll get problems. They'll give you some clues. Use those clues to kind of come up, think about the relationship between the two, and use those clues to find out, to figure out how you could possibly make an equation. That's usually what the goal is in algebra, is use this somehow, make an equation, solve your equation. So.
All right. Awesome. Thank you.
You're welcome. Thank you for calling. Call us again if you've got any other questions.
I will do.
Awesome. Thanks. All right. So what's next? Are we doing?
Okay, so I was just going to ask today's trivia question one more time. Once again, the trivia question for today was, what can you use to identify dogs like you would fingerprints in humans?
Awesome.
Please.
So if you have an answer to that question, just give us a call. We do have a prize. So call us and let us know. And you can also guess, too. So that number there is 720-424-1666. That's the best way to get your prize from us. So, all right. So we had a call. I think we have another social media question from Lily that we can get answered.
So this one asks, state the law of conservation of energy, and it says a mass of 4 kilograms is dropped from a tower of a height of 45 meters. Calculate the potential energy possessed by the body when it is at the top of the tower.
Okay, well.
Almost sounds mathy.
So this is a science math question, and really, Becca, I'm going to lean on you if I can to be
totally fine.
My scribe here.
All right, all right.
So let me start with,
for you.
I guess this is 2 questions. I didn't realize it at first, but it looks like first they want me to state the law of conservation of energy. So let me just say that the law of conservation of energy is simply the idea that energy is neither created nor destroyed. It simply changes form. So if you can imagine any energy in the world, that energy came from somewhere else. It was not created out of nothing. It was transferred from one thing to another. Like, for example, the energy that plants have comes from the sun. It just doesn't come out of thin air. So let's take a look at the maybe more pertinent part of this question. I'm not quite sure what the connection there is, but I'm going to have Becca help me out here with the math.
All right. So I wrote down all the information. They said, again, that the mass of this object was 4 kilograms, and then it's dropped from a tower at a height of 45 meters, and then they wanted to know what the potential energy was of the body at the top of the tower.
Yeah, so we're going to imagine a rock suspended, I guess, 45
my little tower.
Meters up in the air, a 4 kilogram little rock, or maybe I don't know what people are dropping on people from towers these days. Whatever it is, and it weighs 4 kilograms. Boop. Okay, and then if you've got space on there, Becca, could you write out what a newton is? Because we're going to get our answer in newtons.
Okay.
And that's just something that I want to explain. So a newton is equal to a kilogram meter per second squared, which I know is a mouthful.
Did I write that correctly?
Let's take a look here. Kilogram per
meter second times second.
Yeah, no, that's exactly it. No, sorry, yeah, a kilogram meter per second square. So maybe if you just put a little multiplication sign in between the kilogram and meter there, oh, that is perfect. Okay, so this is the definition of a newton. And a lot of times in physics classes, I think what we can have with students is we get this confusion over, well, I got my answer in newtons, but what is it? And what we're going to see is that the kilogram, the meters, and the seconds, they all come from our equation. Okay, so I know I've got you writing a lot of stuff on there, but
okay.
What we need to do is have the equation for potential energy.
Okay.
Now, okay, so we want to calculate, and this is gravitational potential energy. So in other words, anything that's hanging up in the sky, what is the potential energy of this thing dropping to the ground before it drops to the ground?
All right.
So the formula is potential energy is equal to mass, which we're going to represent with m, the acceleration of gravity, which we'll represent with g.
So mass, I'll just say m times g.
Yes, sorry, m times g
okay.
times h.
So m times g times h. These are all time.
Exactly, and that is the equation for potential energy. Mass is going to be mass in kilograms. G is going to be the acceleration of gravity.
Negative 9.8 meters per second.
Per second, that is fantastic. Per second squared.
Yes, indeed. Yeah.
Indeed, but perfect. So maybe you want to write that somewhere. That has to be a given, and so.
So gravity, yeah, it's always the same, right? I mean,
on the Earth, it is always the same. So once in a while, you'll run into these science teachers who will teach you about using this equation, and then they'll give you the gravity on Mars, and make you figure it out for Mars. But
Right.
let's say that for the most part, yes, 9.8 meters per second per second.
Makes sense.
Okay, cool. So this is another one of these situations where if we just know what is being asked of us, if we get the vocab and get the question, this is actually a very straightforward equation.
Bye, tower.
So, okay, bye-bye, tower.
I needed some room.
That's totally fine. All right, so let's just plug in these numbers here. So the numbers are going to go like this. We've got first our mass, okay, and that's given to us in the problem. The mass is 4 kilograms. And the mass for this equation to work correctly always has to be listed in kilograms.
So do I need to write them in the equation?
Like kilograms, for example? I would appreciate it if you could include units.
Okay, if I did leave it written, the units.
Yes, that would be great.
Okay, I agree, I like that. Okay, so we'll say 4 kilograms.
4 kilograms, okay, times, now we're doing times the acceleration of gravity, just like you said, it's negative 9.8 meters per second squared. And yes, absolutely. So, okay, so, and then we're going to multiply, the last piece is the height, and the height is 45 meters. And then it's literally just a question of multiplying across.
Oh, okay.
So
well,
maybe you can
good
do
thing
that
I've
with
got
the
my calculator
there.
here.
Perfect.
So 4 times negative 9.8 times 45.
That's it.
Is going to give you, and it's a negative number, so what does that mean?
Oh, that's a great question, right? So I think in physics we get these negative numbers, and a lot of times you might say, well, what's negative energy? In physics, the negative is actually the direction. So we're talking about this is energy pointed downward. Okay, this is potential energy going downward. If it was a positive number, it would be energy going upward. But this is potential energy directed downward.
Almost like a vector.
It is a vector.
It is a vector.
So yeah, the acceleration of gravity is a force, and so it must be a vector quantity.
Awesome.
All right, so I think that wraps it up. If that made sense to you,
there's
Becca.
The potential energy. It's a lot. All right,
Okay.
so let's go back to Lily and the trivia queen and get our answer for a trivia question. I'm dying to know.
So once again, our question today for the trivia was, what can you use to identify dogs like you would do with fingerprints in humans? And that would be, you can use their nose prints. Oh my goodness. Oh,
That was so cute.
oh,
What a
how
cute answer.
so cute graphic.
So cute.
Love it.
So basically, your fingerprint in humans are unique, unique, where nobody else has the same exact fingerprints. Same way with dogs, their nose print, it's all unique as well.
Yeah, and it turns out it's the same in cats, so you can do the same thing with cats. You can cat print a cat by checking its nose print.
Its nose as well. Makes a lot of sense. So sometimes they will actually, I've never seen them do this with my dog. Maybe they do it, I don't know. But they could actually take a dog print the same way you do a fingerprint with ink, or a nose print, sorry, the same that you would with ink and a fingerprint. Maybe for records for insurance, vet records, things like that. But what makes it so unique basically are the bumps and the ridges on it. Kind of like our fingerprints. We've got these ridges, that are creating this unique pattern in it.
Yeah, that's so interesting. And almost, I would think that I would have heard of somebody doing this at some point, like, oh yeah, I got my dog nose printed just in case he ever gets lost. I'll be able to find him, but I've never heard of that before.
Yeah, me neither. But one of the reasons could be for records for insurance. I don't know.
Yeah, that does make good sense to me.
Possible. Maybe also like to uniquely identify your dog and not, if there's any sort of legal anything of like.
Yeah.
This is not my dog, but he looks just like Fluffy. I don't know. You could identify them, right? Who knows?
Huh. Well, it's really interesting. So different animals have different ways that we might identify them. So another interesting identifying characteristic of an animal is the whale's tail.
Okay.
So just like.
Is that unique?
So in whales, and I can't tell you exactly what kind of whales, it might be all of them, but in whales in general, you have unique tails, some sort of a unique indicator in their tail that allows us to tell any two whales apart.
So whales, cats, you said you could use the cat nose prints. Anything else?
I don't know, Lily, you got anything?
Actually, yeah, there was, well, mine said that they say that dogs are more like humans than chimpanzees, which maybe social behavior wise, but I wouldn't say obviously like that, but yeah, thought it was pretty interesting.
So
I totally agree with that. Totally. Well, anyways, we're out
Very
of time,
cool.
so watch us tomorrow. Again, from 4:30 to 5:30. Check our Facebook, send in some questions, and we'll see you then. Thanks for joining us today.